is first of all going to leave, or this chloride is lost and forming a cation. It is a rate determining step. Okay. And what is the product? Axial product is in the presence of OH minus, that is hydroxyl, the nucleophile is going to be substituted. The Cl is going to be substituted by OH. Okay, this is the rate determining step. This is the slowest step. This is a slow step. Okay, I will show the PPT also, but in general, I want to discuss them first. Then in the second step, this is the fastest step. The formation of cation is a slow step. It is nothing but a cation. It is called as Sn1 reaction. Why it is called as Sn1 reaction? Because rate is equal to K into the molar concentration of this alkyl halide, Rx. That's why it is called as the unimolecular nucleophilic substitution reaction. Okay, what is a nucleophile? A nucleophile is having affinity or attraction towards positive charge. That is why it is called as a nucleophile. Here, Cl is there as well as OH minus is there. This Cl, chloride, is called as a leaving group. Okay, if you see the Sn2 reaction, there you are going to come across this leaving group. Here, this Cl is said to be the weak nucleophile, whereas this OH is the strong nucleophile. Okay, then let us see another one, that is Sn2 reaction. I think you had got the concept. What is Sn1 reaction? Here, the rate of the reaction is depending only on the molar concentration of the reactant, not on the base or the OH minus. Whereas in Sn2 reaction is different. What is Sn2 reaction? Sn2 reaction, and another important thing is that here in Sn1 reaction, racemic mixture is formed. That is, the OH can attack either from the back side, because it is nothing but an sp2 hybridized carbon. Actually, it is sp3 hybridized carbon is converted into sp2 hybridized carbon. Okay, it is sp2 hybridized carbon. In sp2 hybridized carbon, it is a trigonal plane. It is like a plane. The OH can attack either from the top of the plane or from the bottom of the plane. There are two lateral sides of the plane. Therefore, the OH can attack from either side. If it attacks from one side, it forms plus. If it attacks from the other side, it is going to form minus. As a result, 50% of plus, that is dextro, and 50% of levo are possible here. Okay, therefore, it is forming a racemic mixture. Another important thing is that in this one, the polar solvents favor this Sn1 reaction. Okay, polar solvents favor Sn1 reaction. Okay, then why polar solvents like H2O or NH2, that is NH3 ammonia, like this yesterday, we had discussed what are polar solvents. Polar solvents are going to favor this one because they are going to stabilize the cation. This trigonal planar cation is stabilized by these polar solvents. Okay, Rajni, what is your problem? Any problem, Rajni? Can you hear me? Yes. Cheppamma, Rajni.
Nothing, sir, by hand touch.
Okay, Sn2 reaction is a bimolecular nucleophilic substitution reaction. Generally, if you take up another molecule like ethyl chloride, it is nothing but ethyl. There are two carbons. Okay, this one is going to form, or is going to, for example, is having one methyl group is there, one hydrogen is there, and another hydrogen, or let us take some other, like, or ethyl also, methyl group is there, another methyl is there. Let us assume that it is ethyl group. Now, in this one, it is nothing but a chiral compound. In this one, if you take OH minus, it is going to be called as a concerted reaction. It is going to form a complex, a transition state like this, where the chloride is slowly getting dissociated, partially getting dissociated, and this OH minus is going to be partially formed. The newly formed bond, it is a transition. It is an intermediate that is formed here. One is Ca2H5 is there, another one is H is there, another one is CH3 is there. Another one is H is there. Okay, here sp3 hybridized carbon is again converted into sp2 hybridized carbon. It is converted into sp2 again. It is planar. And in this sp2, we are having one p orbital lobe is there. This p orbital lobe is going to interact with both. On both ends, it is having two lobes. It is having two lobes like this. These two are going to be interacted with this two, that is OH as well as chlorine. And finally, this chlorine is lost. Cl minus is lost, and it is forming a compound which is completely inverse to that of this one. Okay, this one is OH is going to come on this side, and we are having CH3 is there and C2H5 is there. C2H5 like this. Okay, this is called as Walden inversion. Okay, this is nothing but Walden inversion is going to happen here. Okay, as I said, in Sn1 reaction, it is racemic mixture is formed, whereas in Sn2 reaction, Walden inversion takes place in Sn2 reaction. Okay, this there is no formation of cation in this Sn2 reaction. Therefore, it is not. It is stabilized by non-polar solvents. Okay, that is this one is favored by non-polar solvents instead of polar solvents. Okay, non-polar solvents like benzene, acetone, dimethyl sulfoxide, okay, DMF, dimethyl formamide, like that, acetone, all those are nothing but non-polar solvents. Non-polar solvents favor Sn2 reaction, whereas polar solvents favor Sn1 reaction. Okay, the same thing. Let us go through some examples of Sn1 reaction as well as Sn2 reaction now. Okay, that is let us see some examples of this two, that is Sn1 as well as Sn2 reactions. Okay, that is a mechanism of nucleophilic substitution in carbonyl group. We will see about this type of substitution also that takes place in carbonyl group. In carbonyl, also nucleophilic substitution takes place. After discussing this Sn1 as well as Sn2 reactions, let us go into that topic, where here what is going to happen is a nucleophile is added to this con, and it is forming a tetrahedral compound transition state. Okay, tetrahedral transition state is formed, where this one is a sp2 hybridized carbon, it is sp3 hybridized carbon, and immediately it is going to lose, and finally a substitution is taking place. It is also nucleophilic substitution. Chlorine is substituted finally by NH2 group. This takes place in carbonyl compounds. Okay, the nucleophilic substitution in carbonyl groups involves the removal of one of the nucleophile. A weak nucleophile is going to be substituted by a strong nucleophile. Whereas in Sn1 mechanism, as I said just now, for example, let us take this benzyl chloride. The benzyl chloride, the leaving group is going away first. Okay, this is nothing but the leaving group. Whichever nucleophile that leaves the compound is called as a leaving group. And in this leaving group, what is going to happen is, let us take another nucleophile, which is strong nucleophile, then chloride. Then it is going to attack this one. Okay, what is the important thing is that a carbocation intermediate is there in this reaction. Therefore, it is Sn1 reaction. Coming to the Sn2 mechanism, nucleophile attacks at the same time. It is called a concerted reaction. Why? Because it is attacking in a single step. Okay, that is PHS minus. Okay, that is going to attack this one, and chloride is removed, and it is forming a tetrahedral compound. Therefore, it is a concerted reaction. There is no involvement of any of the cation. Therefore, this is nothing but Sn2 reaction. Okay, here there are two concepts that are most important. One is basicity can be viewed as a nucleophilicity towards a proton, and nucleophilicity towards carbon must be related. So if we want a fast reaction, we should use NaOH rather than Na2SO4 in this reaction. Okay, in this reaction, if you want a fast reaction, especially in Sn2 reaction, or if you want to substitute OH minus instead of this one, you have to use any OH. Why? Because nucleophile is most important. Okay, that is rate constant K2. We know what is meant by the second order reaction. Sn1 mechanism, if you see again, okay, this is nothing but a tertiary alkyl bromide. It is giving this one, that is a cation, carbocation intermediate is formed. In the presence of OH minus, it is giving a 50% of plus as well as 50% of minus. Why it is like this? Just now I discussed about even this one also. Here, this carbon is, what type of carbon it is? It is sp3 hybridized carbon. It is nothing but an sp3 hybridized carbon. Okay, therefore, it is converted into sp2 hybridized planar. Okay, trigonal planar. It is sp2 hybridized. Okay, this is about the mechanism. In this sp2 hybridized plane, it is like a plane. The OH minus can attack either from the bottom or from the top of the plane, or on both sides, on lateral sides of this plane, the OH minus can attack. Therefore, there are two possibilities. Therefore, that ultimate products are also two. That is, racemic mixture is formed. Okay, there is another mechanism. We will see it later about this one. Sni mechanism is different. The rate of Sn1 depends on the carbon skeleton. Okay, it depends upon the carbon skeleton, whether it is tertiary or secondary or primary. Why? Because tertiary is more stable. The carbocation intermediate that is formed, we know that tertiary is more stable than secondary, is more stable than the stability order. Depending on the stability order, it is primary is least stable. Therefore, carbon skeleton is going to decide which one is favorable. Okay, that is, this is a tertiary. Therefore, Sn1 usually occurs at this one. The leaving group, along with the usual factors of temperature and solvent, but not the nucleophile. The attacking nucleophile is not going to decide the rate of the reaction. Okay, why? Because it is independent of the nucleophile that is attacking. Stable carbocations react by Sn1 mechanism, while others have no choice but to react with Sn2 mechanism. Okay, that is about this Sn1 mechanism. Sn2 mechanism. If you see this Sn2 mechanism, the OH minus is going to attack this alkyl halide in a concerted step. In a single step, they are going to attack, and as a result, a transition. Okay, that is, it is like a wheel. It is the spokes of a wheel are there. Okay, oka wheel laga undi, dantlo cycle pullal laga idi ivanni unnai. Okay, it is like this one, this transition state, which is having 5, out of this 5, 2 are partially formed and one is partially getting dissociated. Okay, and finally it is giving a inverted compound. If you take plus, you will get minus. If you take minus, you will get plus. Therefore, this inversion is called as Walden inversion. Okay, Sn1 and Sn2 mechanism, Sn1 reaction. In methyl halide, it is a primary halide. Therefore, there is no choice for Sn1 reaction. Whereas it is very good for Sn2 reaction, it is favorable. Whereas primary also the same. Methyl is simple, only one carbon containing organic alkyl halide. Whereas this one is primary, therefore we can say that tertiary is the excellent one for Sn1, and Sn2, it is the methyl is very good, primary is also very good, whereas tertiary is the least possible reaction. Okay. Again, we can explain the same thing with the help of this energy profile diagram. Okay, where this energy profile diagram clearly says that in Sn1 reaction, there are two, that is crests are there. This is transition state, formation of carbocation, whereas this is the second state where it is going to attack. There are two steps. The graph also clearly depicts that there are two steps in Sn1 reaction. Okay, this is the planar structure of the carbocation. Less repulsion between the bonding pairs of electrons. Therefore, more repulsion between the bonding empty sp3 orbital. Therefore, sp2 is favorable. sp2 is favored because the repulsion is not existent, is non-existent here. We know that there are certain anions, which are going to stabilize this carbocation. In that way, by using these anions, the carbocation is separated. Okay, that is PF6 minus, SBF6 minus, BF4 minus. Okay, they are non-nucleophilic anions. They can stabilize this carbocation. Okay, that is, in that way, carbocation was first of all separated by a scientist who got Nobel Prize for separating them. Okay, why they are, the question is why they are more stable. Okay, they are extra stability of them is mainly because of, okay, a carbocation can be formed only if it is extra stabilized. What is the reason for the extra stability? Okay, if you see this one, it is tertiary. Okay, tertiary means there is an interaction between the CH sigma donation in empty p orbital of planar carbocation. This is empty p orbital of the planar carbocation is having an empty p orbital. Okay, this empty p orbital is stabilized by the bonding, extra bonding formed by the CH bond. Okay, that is here we know that HOMO and LUMO concept. The LUMO of this one and the HOMO of this are going to interact. That is one factor. Weak donation of sigma bond electrons into the empty p orbital of the cation is one of the reasons for the extra stabilization. And another reason is plus I affecting nature of the alkyl groups. Plus I affecting all these alkyl groups that are bonded are plus inductive effect. Okay, that is, they are going to induce electrons or repel electrons towards this carbocation, and the charge density is decreased. In that way, we can say that there is an extra stabilization. If the alkyl groups are more stabilized, if the alkyl chain is long, it is stabilized more. Why? Because there is every possibility for the interaction between the empty p orbital and them. Then let us see some Sn1 reactions. If you take this one, tertiary butyl alcohol, in the presence of acid, okay, why acid is required? Can anybody tell me here? What is the reason for the acid requirement here? H3PO4 is required in the reaction. Will it undergo Sn1 reaction or Sn2 reaction? Okay,
Sn1.
you can type in the chat box also. Which reaction here? Sn1 reaction. Why this H3PO4 is required? Because H3PO4 will, what does it going to do? It is going to protonate this one for the removal of this H2O, and finally cation is formed. That is why it is Sn1 reaction. And similarly here also S minus, thioalcohol, thiophenol. Okay, it is nothing but thiophenol. It is going to act as a nucleophile. It is going to displace this OH group. Similarly, we can have H3PO4. It is undergoing, that is, it itself is going to, that is the intermolecular or bimolecular product is formed. Here also, the chlorine is removed in the first step, and finally alcohol is going to be formed. Okay, that is alcohol because of the hydration. And one more important thing is that it is a bridged cation are not at all formed. Therefore, they will not undergo this Sn1 reaction. Okay, bridged cations will not undergo Sn1 reaction mainly because they are not stable. Bridge head carbocations are not at all stable. They will not be formed. Okay, there is a rule called as Brett's rule that says that bridged cations are least stable. Okay, the allyl cations. Allyl cations are more stable, therefore they undergo Sn1 reaction easily. One thing is that for Sn1 reaction, stability of the carbocation is most important. Okay, then.
Tertiary is greater than secondary and
Okay, then here let us take hexanol. Okay, cyclohexane with double bond. It is forming a carbocation which is delocalized, similar to that of allyl cation. Therefore, a cation is stabilized. And finally, it undergoes, it gives this allylic bromide is formed. It is also undergoing or giving Sn1 reaction. That is, they will ask you only this question directly. ఇది ఇచ్చి మనకు HBr అని question mark ఇస్తాడు. Okay, you must be in a position to do this one. Then but-2-ene-1-ol. Here also allylic cation, but it is extra stabilized by delocalization. Therefore, the product formed, if you see this one, 80% product is formed at this end and 20% product is formed at this end also. There are two. The mixture of these two compounds are formed because of the delocalization. Okay, they are both. If you start with any of these, ఏది తీసుకున్నా సరే మనకి ఇక్కడ రెండు ఉన్నాయి మనకు రియాక్టెంట్స్. ఈ రియాక్టెంట్ లో ఎక్కడి నుండి స్టార్ట్ అయినా ఈ రెండు సేమ్ మిక్చర్ వస్తుంది. Okay, we are going to get this mixture of these two. This is because of the delocalization. This is called as regioselectivity. Is determined by steric hindrance. Attack is faster at the less hindered side. Okay, why? Because it is nothing but regioselectivity. Okay, that is here. It is going to attack at this end instead of the middle one. Okay, the third carbon. It is going to attack on the first carbon because there is steric hindrance. This is nothing but regioselectivity. Okay, it's mainly because of steric hindrance. Then if you 2-methyl-3-butanol, okay, prenyl bromide. Here also it is a branched one. Just now we had taken only a single without the substituent. It is giving 1-bromo-3-methyl-butene. It is nothing but prenyl bromide. Okay, why? Because it is only 100% compound is formed. If you see this one, here 20% of this compound is formed, whereas here we are getting only 100%. Why? Because on this side it is highly sterically hindered. This carbon is not going to be attacked no more. And another one is here it is because of the delocalization, it is going to shift to these two and bromide, prenyl bromide. This is nothing but prenyl bromide is formed. Okay, then this is nothing but toluene. Okay, or a benzyl halide, benzyl chloride, like that. Benzyl chloride also will give benzyl cation which is stabilized, and this benzyl cation is extra stabilized because of the delocalization. Therefore, it also undergoes many substitution reactions based on Sn1. Okay, when 3 benzene rings are there like this. Okay, there are 3 benzene rings, it is more stabilized, therefore it also trityl cation. It is called a trityl chloride. Okay, trityl cation is going to be forming fast trityl ether is formed. ROH is going to attack and this base is going to remove this proton. Okay, it is also, okay, one thing is that whenever you come across all such cations are more stable, there is some relation between the stability of the cations as well as Sn1 reactions. Okay, in the presence of pyridine, it is going to give this compound. Okay, we can easily imagine this one. HCl is removed. Okay, HCl is removed here. We are removing this HCl and finally forming this compound. Okay, మనము ఎగ్జామ్ లో ఇస్తే గుర్తుపట్టగలగాలి. ఓకే, స్టెబిలిటీ ఉందా లేదా. ఓకే, ఇక్కడ in Sn1 reactions, as I said just now in the one of the slides, that there are some factors that are going to decide the Sn1 reaction. One is the carbon skeleton. We had discussed about the carbon skeleton. Second point is the leaving group. The leaving group is also going to decide. Okay, therefore, let us see the leaving group. Okay, the leaving group, the best leaving group, it is clearly easiest to break Ci bond and most difficult to break CF bond. Iodide sounds to the best leaving group. Okay, iodide is a best leaving group, whereas fluorine is not the best leaving group. How are you going to decide them? Depending on their leaving groups, 118 is the strength of CX bond. Iodine is 54 is the length, is the strength of this kilojoules per mole is the strength of Ci bond. How are you going to decide them? Depending on, for example, you have to take the hydrogen acids, HX. HX is going to dissociate to give H plus and X minus. H plus X minus. This X minus is called as the conjugate base of this acid. Conjugate base of this acid. If acid is strong, then it will be weak. It will be weak. Weak nucleophile. If acid is strong, we know that Hi is a strong acid, then HCl. Hi is a strong acid, then HCl. Therefore, depending on the pKa values, pKa is positive, means it is a good acid. Therefore, it is that is weak nucleophile. A weak nucleophile means easy leaving group. Cl minus is a strong nucleophile, therefore it will not be replaced easily by iodide. For example, if you are having a compound like this, iodine in the presence of chloride, what is going to happen? This iodine is going to be replaced by chlorine, whereas reverse is not possible. If you take tertiary butyl chloride and react with iodide, it is not going to form. This reaction is not possible. What is the reason? Because chlorine is that is not a good leaving group, whereas iodine is a good leaving group. That is the main concept behind the leaving groups. Okay, that is leaving groups we have studied. OH leaving group. OH is never a leaving group. A hydroxide ion is very basic, and if the nucleophile were strong enough, it would be more strong enough to remove the proton from the alcohol. Okay, we cannot remove this OH easily. So therefore, what we had to do is we had to acidify it. In order to remove this OH, what we had to do, we had to protonate it. On protonation, hydronium ion is formed, H2O plus is formed by the protonation of this one. Now you can easily remove. Actually, OH minus is not a good leaving group. Therefore, for OH minus, in order to displace this OH minus, what we had to do is, okay, we had to tertiary butyl chloride from tertiary butanol in the presence of concentrated HCl. Okay, displacement of hydroxide never happens. If the nucleophile reacts, it attacks a proton instead. The nucleophile is going to react with the proton. Okay, this OH bond is broken, not the CO bond. Instead of CO bond, this is going to get dissociated. Okay, then substituting a secondary alcohol in acid is by using concentrated HBr. Why? Because it is itself is an acid, therefore it can give this compound. A primary alcohol in acid. Okay, we can substitute primary alcohol in an acid by Sn2 reaction. By Sn2 reaction, we are protonating it, OH2 plus, and after that it is going to replace. Okay, therefore we can easily brome on that is Sn2 reaction. It is an Sn2 reaction only. Okay, are you following? Hello, students? Are just follow Sn1, Sn2 reactions. We are seeing many number of examples here. Okay, make it by combination with an element that forms very strong bonds to oxygen. The most popular choice are phosphorus and sulfur. Okay, better leaving group laga మార్చాలంటే మరొక route ఉన్నది ఏంటంటే PBr3. Okay, we are converting this OH into a best leaving group. Okay, in that way we can easily convert them into a best leaving group. And it is reaction. రెండు ఒకేసారి జరుగుతున్నాయంటే it is nothing but an Sn2 reaction only. Then instead of PBr3, we can also go for tosyl chloride, para-toluene sulfonyl chloride. Para-toluene sulfonyl chloride can be used here. Base, first of all, we have to remove this H. Then we can convert, and it is a best leaving group here. This ES, OMS, methane sulfonyl chloride, methane para-toluene sulfonate, or alkyl tosylate, mesylate are the best leaving groups. Okay, then, and therefore we can easily convert them into best leaving groups. Therefore, they will attack easily. Okay, they will attack. Okay, pyridine is mainly, the purpose of pyridine is to remove this proton. Here also the purpose of this base is to, this pyridine is to remove the proton from this one. It can easily abstract the proton on after protonation, and it can convert into a leaving group easily. Okay, all these are the leaving groups. Tosylate, mesylate, these groups are also important, my dear students. Okay, this Me is there. Me undi. Tosyl derivative of a primary alcohol reacts with this lithium derivative in an Sn2 form, Sn2 reaction. Okay, the tosylate leaving group is represented by OTS minus. It is represented by OTS minus. First of all, it is converted into this tosylate. After converting into tosylate, what we have to do is we can use this compound of alkyl derivative, and it can easily bind with this one. Why? Because it is that is alkyl lithium. It is nothing but that is alkyne, lithium alkyne derivative salt. Okay, if you remove this anion, this anion is going to attack on this carbon, and finally this compound is formed. This is an Sn2 reaction. Okay, and we can use, instead of the leaving groups, diazo compounds. It is a named reaction. This name is not important for you. Therefore, we can convert them again using this base. The alcohol becomes an electrophile. The nucleophile is usually relatively weak. Okay, and there are two other reagents like azo compounds, diethyl azo dicarboxylate. Okay, diethyl azo dicarboxylate is also one of the compounds that is used here. This is about the mechanism. I think it is not useful for you. You can go through them whenever I share this PPT also. Effect of electrophiles. Ethers are stable molecules that do not react with nucleophiles, are widely used as solvents for this reason. Okay, nucleophiles are not going to attack this ethers. Why? Because therefore what we have to do is phenyl methyl ether is there. Impossible, it is going to attack, it will not attack on this one. Therefore, Sn2 attack as sp3 carbon will take place, and MEI is formed, methyl iodide is formed. Okay, therefore it is giving phenyl methyl ether. CO bond is not getting cleaved, whereas this bond is getting cleaved. For that sake, what we have to do is we have to use Lewis acids. Okay, Lewis acids help them in substituting this H group with BBr3, same as that of PCl3 just now we had seen. Epoxides as electrophiles. We know that this is a nucleophile that is attacked, and epoxide. Yesterday also we had discussed about these epoxides. In basic medium, they are going to open the epoxide on one end, and in acidic medium towards the other less hindered side, it is going to be opened. Okay, three-membered ring is easily opened. Therefore, they undergo Sn2 type of reactions only. All reactions in epoxides are Sn2 type of reactions. Okay, amines are going to attack. Therefore, amino group, it is going to be opened, it is anti. In Sn2, what is going to happen? In opposite side, the nucleophile is attacking. Therefore, epoxides are also called as electrophile. They are acting as electrophiles. Okay, making a methyl ether. Methyl ether can be formed. Sn1 reaction are often carried out under acidic condition to assist departure of a leaving group. The alcohol is deprotonated to make an alkoxide. Okay, that is making a tertiary butyl ether can be formed. All are Sn1 reactions. All these examples are for Sn1 reactions only. And this is also a new reaction where you can see this, that is formation of carbocation followed by substitution. Amines. Okay, that is more controlled methods are needed for the synthesis. One solution is to replace ammonia with azide. Azide is replaced with ammonia. Okay, that is what is done here. It is nothing but reduction reaction. X is substituted by this one. Therefore, it is again a nucleophilic substitution reaction only. Okay, Rn3 is formed. Azides react with epoxides. Azides are also reacts with epoxides is also a nucleophilic substitution reaction. To give hydroxyazide is formed. Okay, then it is also a nucleophilic substitution reaction where epoxide is opened and on one end of the chain. Sulfoxide, sulfur nucleophiles. Sulfur nucleophiles, we had seen this reaction also. That is thiophenol, as I called it as thiophenol when NaOH in the presence of N-butyl bromide, it is giving sulfide. Okay, sulfide is formed. What is the use of this one is to remove this H. Hydrogen is removed. And finally, this sulfur nucleophiles are formed. Solvent, as I said, the polar solvents favor first order reaction, non-polar solvents favor second order reaction. And another important concept, my dear students, you must learn is about the nucleophilicity and basicity. What is the relation between them? They are inversely related. If it is a strong base, means it is a weak nucleophile. The nucleophilicity of a reagent must be correlated with its basicity. Basicity means the tendency to donate the lone pair of electrons is called as basic nature. Whereas nucleophilicity is quite different. The nuclei might be correlated as both requires electrons only. Okay, there are two types of nucleophiles. One is hard nucleophile, another one is soft nucleophile. If hard nucleophile is there, it is going to interact by electric attraction and repulsions. Electronic interactions are responsible for hard nucleophiles, whereas soft nucleophiles require only homo-LUMO approach. Homo-LUMO overlap is required for soft nucleophiles. Hard base is one high electronegativity, low polarizability, and is hard to oxidize. Whereas soft base is one in which the donor atom is of low electronegativity, highly and easy to oxidize. Softness is proportional to the nucleophilicity, whereas hardness is proportional to the basicity. That's all. Okay, just have an idea about them so that sometimes it may be asked also. Okay, that is about, this is the graph. We know about how this one is going to be moved. This is primary. Sn2 reaction is favored by primary, and slowly tertiary means it is the graph is coming down. Whereas the rate is going to be increased, enhanced by tertiary. Towards tertiary, I think it was. Okay, then okay, this is another curve, this is another curve. Okay, it is hyperbolic curve, it is parabolic curve. Okay, parabola is a hyperbola for Sn2 reaction. That's all, my dear students. With respect to this Sn2 reactions and Sn1 reactions, we have learned some aspects of them. Now let us see about nucleophilic substitution reactions in carbonyl compounds, how they are going to take place. how the nucleophilic substitution reactions takes place in carbonyl compounds. Okay, leaving groups, as I said, expelled from the molecule like Cl minus, OR minus, all these are nothing but the leaving groups. For example, Grignard reagent, however, it is going to attack, it is nothing but first step is nucleophilic addition reaction followed by elimination reaction. Okay, OR is substituted finally by methyl group. OR is substituted by methyl group. Therefore, it is nothing but a nucleophilic substitution reaction only. Why it is a nucleophile? Me is going to be forming a nucleophile. Generally, I think everybody knows this one. CH3 is having in chlorine, whenever it is bonded to chlorine, it is acting as an electrophile. This is having partial positive charge and chlorine is having partial negative charge. When bonded with magnesium, it is giving CH3 MgCl, CH3 bonded to Mg, magnesium, which is bonded to again chlorine. Here Mg is having +2, whereas this one is having minus. This is minus. Therefore, this positive charged carbon is converted into a negatively charged carbon. Okay, that is, it is a electrophile, whereas this one is a nucleophile. Electrophile converted into a nucleophile. It is nothing but called as ampolang. Okay, therefore here this nucleophile is going to attack on this. Okay, this is a carbon is having positive charge. Okay, it is called as nucleophilic center. Plus charge is there. Why? Because high electronegativity of oxygen, we know that. And this methyl group is going to displace the pi bond as forming a oxo anion. Okay, anion is formed. And finally, this OR in the next step, it is going to be displaced by the formation of pi bond again, OR minus is removed. It is an example of classic example of nucleophilic substitution reaction in carbonyl compounds. Okay, if you see this carboxylic acid derivatives also, acetyl chloride is there, cyclohexanol when reacted, cyclohexyl acetate is formed. In the presence of base, also this reaction takes place. Acetyl chloride, acetic anhydride also, this is the leaving group. This black one is the leaving group. This chloride is the leaving group. Okay, tetrahedral intermediate is formed in all these reactions. We are going to have tetrahedral intermediates. Okay, then are very less stable, therefore they easily remove. Okay, the tetrahedral intermediate is going to lose this chlorine easily, and as a result again substituted compound is formed. Okay, leaving group ability, as I discussed about just now, the excellent one is chloride depending on its pKa value. For an acid, the lower the pKa, it is a strong acid. Okay, for a if it is the pKa is higher, means it is a weak acid. Depending on the pKa values, we can decide which is the leaving group. The best leaving group oda cheppచ్చు. Okay, here amines react with acyl chlorides to give amides. They are giving amides. CONH2 is formed. Okay, this one again is giving a nucleophile. As a nucleophile, it is attacking on this one, on this carbonyl carbon, and oxo anion is formed, which loses this compound, and finally product is formed like this. N-dimethylamine, amide is formed. N-dimethyl amides are also formed if you use secondary amines. If you use ammonia, simple amide is formed. If you use secondary amines, here also secondary amine is used. It is a Shorten-Baumann reaction where you are going to get this compound. Okay, HCl. We have to remove HCl, that's all. Okay, all these are nothing but nucleophilic substitution reaction. Base strength, again, alkoxides are base strength, the strength of the base. As we had discussed just now, if the acid is strong, its conjugate base is weak. Therefore, weaker bases are the good leaving groups. For attacking, it is reverse. A strong base is good attacking group. We are not worried about the leaving group here. Alkoxides are reasonably strong bases. OMe, alkoxides and OH, OMe, OC2H5. Ethyl alcohol kelli proton తీసేస్తే ethoxide ion వస్తుంది. Methyl alcohol నుండి proton తీసేస్తే methoxide ion వస్తుంది. Okay, all these are strong bases. Base, in the presence of base, it is going to again replace this OMe. NH2 is a strong base when compared to OMe. Therefore, NH2 will remain, whereas methoxide is removed easily. Therefore, the base strength also is going to decide the leaving group and the attacking group. Okay, good enough electrophile must be there, good enough, strong enough nucleophile, and better leaving group. These three are the conditions for this nucleophilic substitution reactions. Okay, acid catalyst. Just now we had seen earlier while discussing about nucleophilic substitution also, when OH is not a good leaving group, convert it into a good leaving group. Okay, OH leaving group kadankondi, then protonate it and converts into a good leaving group so that it can be easily left over and finally the product is formed. Acid catalyzed ester hydrolysis, that is transesterification. That is converting one ester into another ester is called as transesterification. First of all, acid catalyzed ester hydrolysis, let us see. OH plus is formed and OR, this is acid catalyzed ester hydrolysis. Okay, CO bond is removed finally. COOR lo, COR bond is dissociated. And finally, COOH is formed. Carboxylic acid is formed. How to remove it? By the hydration. H2O is a nucleophile. It is going to attack on this one, and ROH is formed. ROH by protonation. That is H2O attack takes place in the first step. Second step is the protonation of this alkoxide. And finally, the leaving group is lost, converting itself into ROH as well as COOH. That is called as ester hydrolysis. Ester hydrolysis and idanamata. COOR unnadi. This is nothing but an ester. It is converted into a carboxylic acid. It is converted into a carboxylic acid like this. COOH plus ROH. Alcohol is also lost. దీని కొరకు ఏం చేయాలంటే ఫస్ట్ మనం ఏం యాడ్ చేయాలి, ఇక్కడ OH ను తీసుకొచ్చి OR ను పక్కకు నెట్టేయాలి. OH తీసుకురావడం అంటే H2O, in the form of H2O it is attacking. Then after that, what is going to happen here is, here it is going to form OH on one side and OR. Why? Because in the first step itself, this carboxylic oxygen is getting protonated. In the later on, ROH కూడా protonation, అంటే best leaving group గా మార్చాలనుకుంటున్నా. By protonation is one of the best method of converting a bad leaving group into a good leaving group. Okay, then it is removed, okay, by displacement, and finally carboxylic acid is formed. Okay, that is again a nucleophilic substitution only. This is about ester hydrolysis. Transesterification means converting one ester into another ester. ఒక ఎస్టర్ ను మరొక ఎస్టర్ లాగా మార్చడాన్ని ట్రాన్సెస్టరిఫికేషన్ అని అంటాం. ఇట్ ఈస్ కాల్డ్ as transesterification. Again, by using catalytic HCl. Okay, HCl, what is going to happen? OMe is not a good leaving group, therefore protonate it. దానికి ఏం చేయాలి, మనం protonation చేయాలి. తర్వాత ఇది అటాక్ అవుతుంది. ఓకే, OH2 రూపంలోనే అటాక్ అవుతుంది. దెన్ deprotonation and removal, O minus. Okay, that is nothing but transesterification. OMe is there, methyl group is there. Instead of methyl group, we are having pentyl, 1, 2, 3, 4, butyl group. butyl chain is there here. Okay, this is the mechanism. First of all, oxygen protonation చేస్తున్నాం. Then it is attack same as H2O attack అయినట్టు అంతకుముందు ఇక్కడ ఇది attack అవుతుంది. Then it is replaced and it is getting protonated. Next step, it is getting protonated. Protonation అయిందంటే వెళ్ళిపోతుంది అన్నట్టుగా. Okay, అది విషయం. Then base catalyzed hydrolysis is irreversible. Acid catalyzed hydrolysis is reversible. This is most important, my dear students. That is, all acid catalyzed reactions are generally reversible reactions, whereas base catalyzed hydrolysis of esters is irreversible. Okay, how it is going to take place? It is a OH minus. We know that it is a strong nucleophile in the presence of base. It is going to attack on this one, and finally it is removed. Why? Because it is a strong nucleophile. Strong always replaces weak. That is universal law. Okay, amides can be hydrolyzed under acidic as well as basic conditions. Okay, amides also can be hydrolyzed under acidic or basic conditions. The same steps are used here. H2O protonation followed by H2O. Amides CONH ఏమైతే ఇక్కడ బ్రేక్ అయిపోతుంది బాండ్, COOH వస్తుంది, and PHNH2, that is phenylamine, is formed. Okay, that is again amides can be hydrolyzed under acidic or basic conditions. Both conditions you can hydrolyze amides. The same type of ester ఇంతకుముందు మనం చూసినట్టే సేమ్ రియాక్షన్ ఇక్కడ కూడా. ప్రోటనేషన్ తర్వాత దీన్ని ప్రోటనేట్ చేస్తున్నాం, నెక్స్ట్ స్టెప్ లో దీన్ని ప్రోటనేట్ చేస్తాం, దాన్ని వెలగొడతాం, అండ్ ఫైనల్లీ యాసిడ్ ఈస్ ఫౌండ్, బెంజోయిక్ యాసిడ్ అండ్ ఫినైలమైన్ ఈస్ ఫౌండ్. Basic medium లో అయితే OH minus is going to attack, same as that of ester hydrolysis లాగానే ఇది కూడా. Okay, that is about the carboxylic acid derivatives. Okay, I will share this PPT where you can see all of them. RCOCl is the strongest one. దీన్ని ఇట్లా కన్వర్ట్ చేస్తే OH is not a good leaving group కాబట్టి Cl లాగా మార్చేద్దాం, ఈజీగా మారిపోతుంది. OH Cl అంటే OH బదులు Cl తెచ్చి చేర్చడం ఈజీ అనమాట. ఎట్లా SOCl2 and PCl5 can be used as a reagent. They can be converted into anhydrides or esters or amides. Any of the interconversions are possible like this. This is very important slide where you can interconvert. Okay, making ketones from esters. How to make ketones? Just attack with the Grignard reagent. ఒక Grignard reagent attack అవుతుంది. ఇక్కడ methyl is the nucleophile and it is going to be displaced O minus H. Okay, hydrolysis చేస్తాం, OH వస్తుంది, O minus, and the next step లో ఏమవుతుంది, అది OMe వచ్చేస్తుంది, మళ్ళీ అటాక్ చేస్తాం 2 times. 2 moles of Grignard reagent are required, that's all. OMe is the leaving group here. Okay, OMe is the leaving group, and finally protonation will give this. Ketones are formed which are converted into tertiary alcohols. Okay, esters ku manamu tertiary alcohol laga marcheyచ్చు, just Grignard reagent కలుపుతూ వెళ్ళాలి, or alkyl lithium, butyl lithium, n-butyl lithium. Okay, here unsaturated known as methyl methacrylate. This is a very important compound. Methyl methacrylate is formed from this ester by using 2 moles of butyl lithium. 2 moles of butyl lithium. Direct marcheyచ్చు by just reduction, that's all. H minus is going to, that is hydride is going to attack on the, as a nucleophile is hydride, lithium aluminum hydride low, hydrogen hydride H minus is the nucleophile. Therefore again the same concept, very simple. The nucleophile will attack the carbonyl carbon, displacing the pi bond, and later on again replacing the O minus, and leaving group is lost. Okay, that's all about this nucleophilic substitution reactions we had seen, my dear students. If you are having any doubts, you can ask me. In the next session, immediately within 5 minutes, we will start another session about elimination reactions. Okay, about elimination reactions, let us see. Any doubts? Doubts? Sn1 reaction, Sn2 reaction. What is a leaving group? What is a leaving group identity? What is attacking group? When will the leaving group will be stronger? Many concepts నేర్చుకున్నాం. You go through the video also. Okay. After 5 minutes, we will continue another session for elimination reaction. After completing elimination, we will close today's class. Any doubts? ఎవరైనా మాట్లాడండి. ఏమైనా మాట్లాడండి. Hello, students. Yes, I will give unmute option to you, but there is a disturbance. మీ దాంట్లోనే కొందరు అడిగారు, అందుకనే ఇవ్వలేదు. Okay, now I will give. Okay.
Sir.
చెప్పండి.
Sir. Based on PK value, leaving group is decided అని చెప్పారు కదా.
బేస్ అయితే స్ట్రాంగ్ బేస్ ఉంది అనుకోండి.
ఒకసారి అది మళ్ళీ చెప్పండి సార్.
ఏ స్ట్రాంగ్ బేస్ ఉన్నప్పుడు ఇక్కడ లీవింగ్ గ్రూప్ ఒకటి ఉంది. లీవింగ్ గ్రూప్ కేమో మనము HCl లేదా HX అనుకుందాం. HX స్ట్రాంగ్ అయితే అకార్డింగ్ టు కాంజుగేట్ యాసిడ్ బేస్ పేర్ తెలుసుగా మీకు. కాంజుగేట్ బ్రాన్స్టెడ్ యాసిడ్ బేస్ థియరీ ప్రకారం ఇది స్ట్రాంగ్ అయితే ఇట్ ఈస్ గోయింగ్ టు గివ్ H+ ప్లస్ X-. ఇది తెలుసు కదా మనకు డిసోసియేషన్. ఓకే ఓకే దిస్ వన్ ఈజ్ H+ ప్లస్ X-. X- is called as a conjugate base. If HX is strong, X- will be weak. Okay. X- weak అంటే ఏంటిది? Weak nucleophile అంటే better leaving group. Good leaving group అన్నమాట. Good leaving group ఇది. Okay, then another one is అందుకే మనం ఏమనుకున్నాం F- ఉంది, నెక్స్ట్ I-, Cl- ఉంది, Br- ఉంది, I-. వీటిల్లో I- ఎందుకు గుడ్ లివింగ్ గ్రూప్? ఎందుకంటే HI is a strong acid. Okay, HI hydrogen iodide is a strong acid. Therefore I- is a good leaving group. ఎందుకంటే ఈ బాండ్ తొందరగా బ్రేక్ అవుతుంది ఇక్కడ, అందుకని స్ట్రాంగ్ యాసిడ్. I- is a weak nucleophile, అందుకే గుడ్ లీవింగ్ గ్రూప్. గుడ్ లీవింగ్ గ్రూప్. ఇంకొకటి మనం ఏమనుకున్నాం, అటాకింగ్ గ్రూప్ కూడా చూస్తున్నాం. ఏది? న్యూక్లియోఫైల్ అడిషన్స్ లో అమ్మోనియా ఉంది, లేదా ఇంకొకటి OMe ఉంది, మిథాక్సైడ్, విచ్ ఈస్ ఎ స్ట్రాంగ్ బేస్. Ammonia is a strong base. NH2- is a strong base. ఇదే అటాక్ అవుతుంది. Why? Because we know that it is a Lewis base. Original గానే బేస్ అది. Okay, therefore it is going to attack and it will be the leaving group, best leaving group. నా మారిపోతుంది. ఇంకొకటి ఎంతనా? ఎనీ డౌట్స్?
సార్ ఇక్కడ పీకే వాల్యూ ఎట్లా చూపిస్తుంది సార్? అంటే పీకే ఎఫెక్ట్ అవుతుంది కదా ఇక్కడ.
పీకేఏ వాల్యూస్, పీకేఏ వాల్యూ pH లాగానే, pH తక్కువ ఉంటే బెస్ట్ యాసిడ్ కదా. pKa వాల్యూ తక్కువ ఉంటే గుడ్ యాసిడ్, స్ట్రాంగ్ యాసిడ్ అన్నమాట. దాన్ని బట్టి మన pKa బట్టి దాని కాంజుగేట్ బేస్ ను తెలుసుకోవచ్చు అంటుండే. ఎందుకంటే ఒక యాసిడ్ కు ఉండేదన్ని pKa వాల్యూస్ ఉంటాయి కానీ లీవింగ్ గ్రూప్స్ కు ఉండదు pKa వాల్యూస్. కాబట్టి pKa వాల్యూస్ నుండి we can inference can be drawn regarding this weak or strong nucleophiles గురించి మనం pKa వాల్యూ చూడండి, న్యూక్లియోఫైల్ స్ట్రెంత్ ను మనం చెప్పండి అంటున్నాం అన్నమాట. అందుకే ఓకే, అర్థమైందా? pKa ఎక్కువ ఉంటే ఏమవుతుంది? వీక్ యాసిడ్. pKa తక్కువ ఉంటే స్ట్రాంగ్ యాసిడ్. అంతే. Kaకు ఉల్టా మళ్ళా Ka అంటే వేరు. Ka ఈజ్ ఈక్వల్ టు మైనస్ లాగ్ Ka ఈజ్ ఈక్వల్ టు pKa. మైనస్ లాగ్ Ka ఈజ్ ఈక్వల్ టు pKa. therefore Ka ఎక్కువ ఉందనుకోండి స్ట్రాంగ్, మళ్ళీ రివర్స్ ఉంటుంది. pKa Ka విల్ యాక్ట్ రివర్స్లీ, అంటే రివర్స్లీ కాదు, ఇన్వర్స్ గా. ఓకే, దే ఆర్ ఇన్వర్స్లీ రిలేటెడ్, దే ఆర్ నాట్ డైరెక్ట్లీ రిలేటెడ్. ఓకే, okay. Now let us see about another type of reactions called as elimination reactions. Elimination reactions చూద్దాం. Okay, elimination means we have to eliminate one of the group. Okay, eliminate చేయాలి మనం. Elimination reactions, again, how many types there are? 3 types. One is unimolecular elimination reaction. Another one is bimolecular elimination reaction. Bimolecular elimination reaction. Third one is even CB. Even అంటే unimolecular conjugate base elimination reaction. There are 3 types of elimination reactions. Yesterday I had discussed, I think not for you, same as that of Sn1 reactions. In Sn1 reactions, what is going to happen? Let us take tertiary butyl chloride. Tertiary butyl chloride is going to eliminate. In the first step is Cl minus is lost, and it is forming a carbocation. Carbocation is formed. And in the next step, instead of, we know that in this reaction, if it is attacked by OH, OH is formed, or else if it loses one of the hydrogen ion, H plus ion is lost, and it is going to form an alkene. Double bond is formed like this. Okay, this is called as, what is this one? 2-methyl propene is formed. It is, what is the result? Minus HCl. Minus HCl is taking place. It is nothing but elimination reaction. Here in this elimination reaction, if you see the rate of this reaction is similar to that of Sn1 reaction, where the rate of the reaction is depending only on the alkyl halide. In the rate equation, only one concentration term is there. Therefore, this is called as unimolecular elimination reaction. Okay, unimolecular elimination reaction, because only one of the molecule of this Rx is there. Same as that of the Sn1 ku idi దగ్గరగా ఉంది. Okay, E1, this is called as E1 reaction. Then E2 is different. What is E2 reaction is, that is the removal of hydrogen as well as chlorine will take place simultaneously. Okay, let us take this one, where we are having hydrogen on one side, and there are 2 groups. Let us see. Cl is there. This is another carbon is there. The attack of the base is going to attack base What is the use of the base? Base ఎప్పుడైనా ఏం చేస్తుంది? It removes the hydrogen. Instead of acting as a nucleophile, a base అన్నాం ఇంతకుముందు. Okay, and what is going to be formed? This is going to reaction is taking place in a concerted manner. Concerted అంటే single step laga. Minus HCl takes place. And it is forming, there is no cation that is formed as an intermediate. Therefore, this is again a, what type of reaction it is? E2 elimination. It is E2 elimination. Okay, that is E2 elimination takes place here. Okay, that is first of all, chlorine is lost. In the next step, the hydrogen is also lost. To remove hydrogen, we require a base. If you take a base here, the base may be there here. You will see all those one by one. Okay, first cation form అయ్యి తర్వాత బేస్ అటాక్ అయితే E1. బేస్ లీవింగ్ గ్రూప్ రెండు ఒక్కసారి వెళ్ళిపోతే E2. Okay, third one is E1CB. E1CB is different. Okay, E1CB లో generally takes place in groups like this. Okay, a leaving group which is having carbonyl group, alpha hydrogen must be there here. This is called as alpha hydrogen is a must for E1CB reaction. E1CB లో first base is going to get attacked. Base munduga abstracts the proton, removes the proton, first step. Okay, it is going to remove this proton and it is going to form a minus charge here. Ikkada minus charge ఏర్పడుతుంది. And a double bond is formed and there is a leaving group here, chlorine. అప్పుడు ఏమైతుంది? Because of resonance, ఇక్కడ ఇంకొకటి ఉంటుంది CH2Cl. Okay, I will show all those. It is a conjugate base is formed. Okay, what is going to happen is a conjugate base is formed here. An anion is formed. This is called as conjugate base. And the next step is anion double bond O minus Cl, CH2Cl. CH2Cl is formed, and finally, I will show all this. There is some confusion here. We are seeing about elimination reactions. Okay, elimination, nucleophilic substitution, just now we had seen, whereas here, this is an elimination reaction here. Can you see the screen?
Yes,
Can you
sir.
see the screen? కనబడుతుందా? Okay. Nucleophilic substitution అంటే ఇట్లా ఫస్ట్ స్లో స్టెప్ తర్వాత ఫాస్ట్ స్టెప్ ఉంటుంది. టెర్షియరీ బ్యూటైల్ ఆల్కహాల్ is formed. ఇక్కడ base is attacking in the first step. Isobutane is formed. Okay, it is again that is elimination reaction. It is an elimination reaction, general. Okay, basicity and nucleophilicity are also going to decide whether elimination or nucleophilic substitution takes place. Elimination happens when the nucleophile attacks hydrogen instead of carbon. Okay, nucleophile is attacking carbon here. ఇది చూడండి, OH మైనస్ ఎక్కడ అటాక్ అవుతుంది? ఇక్కడ బాండ్ అవుతుంది. OH మైనస్ కు బాండింగ్ ఎక్కడ వస్తుంది? కార్బన్ ఇస్ ద టార్గెట్. వెరాజ్ హియర్ OH మైనస్ కి ఎవరు టార్గెట్? కార్బన్ కాదు, Instead of carbon, it is attacking on the hydrogen. Hydrogen తీసేస్తుంది. Okay, when it is removing hydrogen, it is giving elimination. అది అంటున్నాను అన్నమాట ఇక్కడ విషయం. Okay, then there is some correlation between basicity and nucleophilicity. ఇంతకుముందు మనం డిస్కస్ చేసిందే మళ్ళీ. Strong bases are usually good nucleophiles. Strong nucleophiles ఉండాలంటే strong base ఉండాలి. Being a good nucleophile does not get hydroxide anywhere in the substitution reaction because it does not appear in the first order rate equation. But being a good base does it somewhere in the elimination reaction because hydroxide is involved in the rate determining step. E2 elimination. ఇక్కడ base and the removal of the leaving group takes place simultaneously. రెండు ఒకేసారి జరుగుతున్నాయి. Then it is called as E2 elimination and the rate is depending on both. On both means alkyl halide as well as OH minus. Okay, nucleophilic substitution of tertiary butyl alcohol with HBr. Okay, that is here substitution reaction. Idi ikkada elimination, even elimination reaction chudandi. H plus deprotonation, cation is formed. Next base HSO4 minus bisulfate ion base can easily remove. But ఇది strong acid weak base కదా, ఈవెన్ రియాక్షన్ లో వీక్ బేస్ స్ట్రాంగ్ బేస్ కు వాల్యూ లేదు. ఎందుకంటే ద రేట్ డిటర్మైనింగ్ స్టెప్ ఈజ్ ద సేమ్ స్టెప్. ద ఫస్ట్ స్టెప్ ఇస్ ద రేట్ డిటర్మైనింగ్ స్టెప్. సెకండ్ స్టెప్ లో ఇది వీక్ ఉన్నా సరే ద బేస్ కెన్ బి ఈవెన్ వీక్ ఆల్సో. వీక్ ఉన్నా సరే ఈజీగా అటాక్ అవుతుంది. ఇట్ కెన్ అటాక్ ఈజీలీ. ఇట్ ఈస్ ఎ ఫాస్ట్ రియాక్షన్. Okay, the HSO4 minus anion is not involved in the rate determining formation and also very bad nucleophile, so it does not attack the carbon atom. This carbon atom no aim attack cheyatledu. It is just a removing the proton. Neither it is basic, but in the mechanism it does behave as a base. Only because it is even more feeble as a nucleophile. Even elimination of ROH. Okay, that is ROH. This is ROH, elimination reaction. Okay, first of all, this bond is formed. A lone pair of electrons are shifted. Hemiacetals. This is nothing but an hemiacetal or ROH. It is removed. First of all, protonation takes place and then later on it is removed. Same manam intamundu chusinatte. And finally, carboxylic acid as well as alcohol is formed of H2O during enamine formation. En and amine formation. Okay, enamine formation lo kuda H2O first protonation cheyali. Cheste ikkada cation vastundi. Ee cation positive charge by delocalization of lone pair of electrons, it is going to form this one. And finally, proton is removed. It is enamine formation. Okay, H2O is removed. అని అనుకుంటాం. సింపుల్ గా H2O వెళ్ళలేదు, నైట్రోజన్ ఇన్వాల్వ్మెంట్ తోటే H2O వెళ్ళిపోయింది. Okay, this is again an example of enamine reaction. Ester hydrolysis లో కూడా సేమ్ ఈవెన్ ఎలిమినేషన్ అయిపోయింది. ఎందుకంటే OR వెళ్ళిపోవాలి, ROH is formed. Attack of carbon leads to substitution. Attack of hydrogen leads to elimination. Strong bases attack protons. It is generally true that the more basic the nucleophile, the more likely that elimination is going to replace substitution as a main reaction of an alkyl halide. A weak base leads to substitution while a strong base leads to elimination. ఇది గుర్తుంచుకోండి. వీక్ బేస్ అయితే సబ్స్టిట్యూషన్. ఎందుకంటే వీక్ బేస్ అయితే అది న్యూక్లియోఫైల్ లాగా యూజ్ అవుతుంది. వీక్ బేస్ సబ్స్టిట్యూషన్, స్ట్రాంగ్ బేస్ ఎలిమినేషన్. ఇథాక్సైడ్ ఇస్ స్ట్రాంగ్ బేస్, ప్రోటోనేషన్ అయితే అది వీక్ బేస్ అయిపోయింది. ఓకే, ప్రోటోనేషన్ ద్వారా వీక్ బేస్, వెరాజ్ స్ట్రాంగ్ బేస్ అంటే ఇథాక్సైడ్ ఇస్ ఎ స్ట్రాంగ్ బేస్, therefore it abstracts the proton. ఇది గుర్తుంచుకోవాలి. ఆల్కైల్ టెర్షియరీ బ్యూటైల్ క్లోరైడ్ ఇచ్చిండు, ఒక దిక్కు ETO మైనస్, ఇంకోవైపు ETOH ఇస్తే ETOH సైడ్ ఏమో సబ్స్టిట్యూషన్ అవుతుంది, ETO మైనస్ సైడ్ ఏమో elimination. In an Sn2 substitution, the carbon center is a soft electrophile. It is essentially uncharged, and with leaving groups such as CX is relatively low energy LUMO. Substitution is therefore favored by nucleophiles whose homos are able to interact with the LUMO. Okay, CX, X is a soft, it would a soft. Okay, because a hard soft acid base theory like soft will form a bond. The reasons that Sn2 is so slow on hindered alkyl halides, the nucleophiles have difficulty getting the reactive center. As soon as we start using basic nucleophiles that are so bulky, elimination becomes preferred. Bulky groups, మనం అవి కూడా ఎగ్జాంపుల్ చూస్తాం. Bulky groups NMe3 plus అంటే టెర్షరీ ఆర్ క్వాటర్నరీ అమోనియం ఉన్నట్టయితే, లేదా N ఆక్సైడ్స్ ఉన్నట్టయితే, లేదా SOCl2 అటువంటివి NMe3 అట్లా, దే ఆర్ బల్కీ గ్రూప్స్, బల్కీ లివింగ్ గ్రూప్. టెర్షరీ బ్యూటాక్సైడ్, పొటాషియం టెర్షరీ బ్యూటాక్సైడ్ ఇస్ ఆల్సో బల్కీ లివింగ్ గ్రూప్. బల్కీ గ్రూప్స్ ఉన్నాయి అన్నప్పుడు అల్లా మనకు E2 ఎలిమినేషన్ అవుతుంది. గుర్తుంచుకోవాలి ఇవన్నీ. ఓకే, అంటే ఈ క్లాస్ ద్వారా మీరు యూ మస్ట్ లెర్న్ E1 ఎప్పుడైతుంది, E2 ఎప్పుడైతుంది అవన్నీ చూడాలి. ఓకే, ఈనాల్ న్యూక్లియోఫైల్ సబ్స్టిట్యూషన్, small nucleophile substitution, it is going to BR-OH అయిపోయింది. అదే tertiary butoxide, potassium tertiary butoxide, large nucleophile, it is acting as a base. ఇక్కడ OH minus, ఇక్కడ potassium tertiary butoxide is there, therefore elimination, it is a strong base. Nucleophile that are strong bases favor elimination over substitution. Nucleophile that are bulky favor elimination over substitution. Strong base that are strong bases, then they favor elimination. Bulky favor elimination. High temperatures favor elimination. These are the factors that favor elimination. ఎందుకంటే మీకు ఒక రియాక్షన్ ఇచ్చినప్పుడు అక్కడ ఎలిమినేషన్ చేయాలన్నా సబ్స్టిట్యూషన్ చేయాలన్నప్పుడు ఈ ఫ్యాక్టర్స్ కన్సిడరేషన్ తీసుకోవాలి. E1 elimination describes an elimination in which the rate determining step is unimolecular and does not involve the base. Unimolecular, first cation form అవుతుంది, తర్వాత బేస్ అవుతుంది, బేస్ అటాక్ అవుతుంది. అంటే బేస్ ఈజ్ నాట్ ఇన్వాల్వ్డ్ ఇన్ ద రేట్ డిటర్మైనింగ్ స్టెప్. రేట్ ఈజ్ ప్రపోర్షనల్ టు K into alkyl halide. E2 elimination లో rate is equal to K into base molar concentration as well as the alkyl halide molar concentration, both. Therefore, it is called as E2 elimination. In E2 elimination, both are involved. Okay. Then E1 and E2 reaction. One is immediately clear that the rate only the E2 is affected by concentration of base. So, high base concentration E2 is favored. Strong base E2 is favored. The rate of E1 is not even affected what base is present. E1 is just likely with weak as well as with strong bases. Strong bases, whatever concentration will favor E2 over E1. Okay, base strength ఎక్కువైతే E2 నే అవుతుంది. Synthesis of diene, potassium tertiary butoxide, E2 elimination takes place. It is an E2 elimination reaction. Okay, HBr ఇక్కడ పోతుంది, ఇక్కడ H, ఇక్కడ కూడా పోతుంది HBr. Okay, potassium tertiary butoxide, OET, HBr is lost. Ethanol is used for substitution. It is nothing but an acetal form అయిపోయింది. It is forming acetal. ETOH and diethyl ketene acetal. Diethyl ketene acetal. E2 elimination takes place. Okay, it is also a strong base. DBU is a strong base, therefore E2 elimination. Okay, it is undergoing ikkada H తీసేస్తుంది, ఇక్కడ I. It is also a strong base. It is abstracting hydrogen. See, ఇక్కడ ఉన్న హైడ్రోజన్ ను తీసేస్తుంది. Okay, 1,8-diazo bicyclo undecane 7. The starting material is a tertiary and therefore substitute only by Sn1, but it can eliminate by either Sn2, E2 or E1. Tertiary alkyl halide Sn1 లోనే సబ్స్టిట్యూషన్ అవుతుంది, కానీ బేస్ని బట్టి అది E2 నా E1 అని చెప్పవచ్చు. అంటే టెర్షియరీ ఆల్కైల్ హ్యాలైడ్ అన్ని E1 అని చెప్పలేమన్నమాట. The steric factors that disfavor Sn2 at Hiner does not exist in elimination. Steric factors are not going to be there in elimination reactions. Okay, all these are undergoing even elimination reactions only. I will wind up, don't worry. This compound does not undergo elimination by either E1 or E2 reaction. Why? Because non-planar structure forces the cation to have an sp3 hybridized carbon. ఇక్కడ రియాక్షన్ జరగదు అంటుంది. బ్రిడ్జ్ హెడ్ OH ఉంది, ఇది పోతే ఏమవుతుంది, అది sp2 లాగా మారిపోతుంది, క్యాటయాన్ వస్తుంది. లేదా అప్పుడు sp3 హైబ్రిడైజేషన్ ఆల్కీన్స్ అయితే కూడా sp2నే, కాబట్టి ఇట్ ఈస్ గోయింగ్ టు లూజ్ ఇట్స్ హైబ్రిడైజేషన్, టెట్రాహెడ్రల్ స్ట్రక్చర్ పోతుంది. కాబట్టి దే ఆర్ నాట్ గోయింగ్ టు అండర్గో ఎలిమినేషన్ అట్ ఆల్. ఇట్ ఈస్ నాట్ గోయింగ్ టు అండర్గో ఎలిమినేషన్. బ్రెడ్స్ రూల్ అదే, induced by planar bridgehead carbon. దీన్నే బ్రెడ్స్ రూల్ అంటాం. ఇంతకుముందు మనం చెప్పుకున్నది బ్రెడ్స్ రూల్. ఓకే, I think you will. There are two types of products. One is Hoffman product, another one is Sedzeff product. Poor becomes poorer is Sedzeff product. See here it is an even elimination reaction. ఎందుకు ఈవెన్ అంటున్నామంటే యాసిడ్ మీడియంలో అవుతుంది. ఈవెన్ ఎలిమినేషన్లో విచ్ ఈస్ పూర్, హియర్ వీఆర్ హ్యావింగ్ టూ, దట్ ఈస్ OH. ఇక్కడ వన్ సైడ్ వచ్చే ఛాన్స్ ఉంది, ఈ ఆల్కిన్ జెడ్ ఆల్కిన్, బికాస్ ట్రాన్స్ ఈజ్ ఈజీలీ ప్రిఫర్డ్. మోర్ సబ్స్టిట్యూటెడ్ ఆల్కిన్ ఈజ్ మోర్ స్టేబుల్. ఓకే, దెన్ elimination and stereochemistry also we can see this one. E alkenes are preferred in even elimination. E alkenes are preferred in even elimination. ఎందుకు చెప్పండి, ఈవెన్ ఎలిమినేషన్ లో క్యాటయాన్ ఉంటుంది. క్యాటయాన్ ఉన్నప్పుడు క్యాటయాన్ కొంత టైం ఉంటుంది, ఆ టైం ఉండడం వలన అది స్టేబుల్ వైపే ఓరియంట్ అవుతుంది. విచ్ ఈస్ స్టేబుల్, వి నో దట్ ట్రాన్స్ ఈజ్ మోర్ స్టేబుల్ దెన్ సిస్. క్యాటయాన్ కెన్ convert into a trans alkene easily rather than cis alkene, ఎందుకంటే the intermediate carbocation is there which is a transient అంటే కొంత లైఫ్ ఉన్నది దానికి. That's why it is about that one. Then here regioselectivity ఇప్పుడు చెప్పుకున్నాం ఇంతకుముందు. Sedzeff ప్రోడక్ట్, ఇంకొకటి హాఫ్మన్ ప్రోడక్ట్ అని. Sedzeff ప్రోడక్ట్ ఏమో ఇదేమో హాఫ్మన్ ప్రోడక్ట్. ఓకే, మోర్ సబ్స్టిట్యూటెడ్ ఆల్కీన్స్ ఆర్ మోర్ స్టేబుల్ అనేది ఇక్కడ మనకు Sedzeff ప్రోడక్ట్, హాఫ్మన్ ప్రోడక్ట్ ఇట్లా ఎక్స్ప్లెయిన్ చేయొచ్చు. ఇక్కడ ఎన్ని హైడ్రోజన్లు ఉన్నాయి, మనకు 3 హైడ్రోజన్ ఉన్నాయి. దెర్ ఆర్ 3 హైడ్రోజన్స్ హియర్. ఓకే, ఇక్కడ ఇదొక హైడ్రోజన్, ఇదొక హైడ్రోజన్, ఇదొక హైడ్రోజన్. ఇక్కడ ఎన్ని హైడ్రోజన్లు ఉన్నాయి, 1 2 3, ఒక్కటే హైడ్రోజన్ ఉంది. పూర్ బికమ్స్ పూరర్ అంటే ఆల్రెడీ ఒకటి ఉన్నది, దాన్ని తీసివేస్తారు అనమాట. దేర్ఫోర్ ఇట్ ఈస్ రిమూవ్డ్, దాన్ని తీసేస్తాం. అప్పుడు డబుల్ బాండ్ ఇట్ షిఫ్ట్ అవుతుంది, ఇది అట్లనే ఉంటుంది. ఓకే, రిచ్ బికమ్స్ రిచర్, లేదా అది మార్కోని కప్స్ రూల్లో పనికి వస్తుంది. ఇక్కడ పూర్ బికమ్స్ పూరర్, ఎటువైపు అయితే తక్కువ ఉన్నాయో, యాక్చువల్గా రీజన్ అది కాదు. హయ్యర్ బ్రాంచ్డ్ ఆల్కీన్ ఈజ్ మోర్ స్టేబుల్, దట్స్ ఆల్. వై? బికాస్ ఆఫ్ హైపర్ కాంజుగేషన్స్ అండ్ అదర్ ఫ్యాక్టర్స్. ఓకే, మెసోమెరిక్ ఎఫెక్ట్ అవన్నీ కనబడతాయి మనకు. That is called as regioselectivity. E2 eliminations and stereoselective reactions. Stereoselectivity where stereospecific reactions where. Okay, then here just now we had seen major minor product unte, that is called as stereoselective reactions. Stereospecific ante oka compound okate specific ga iste danni stereospecific reactions anta. Okay, here all are stereoselective reactions, major and minor. ఒకటి ఎక్కువ వచ్చింది, ఒకటి తక్కువ వచ్చింది. ఎందుకో రీజన్ చెప్పుకున్నాం ఇప్పుడే. దూరంగా ఉంటే 2 మిథైల్ గ్రూప్స్ అండ్ టైప్ లెస్ హిండర్డ్. ఇక్కడైతే సిస్ అయితే 2 మిథైల్ గ్రూప్స్ గౌషే అంటే దగ్గరగా ఉంటే దే ఆర్ మోర్ హిండర్డ్. దేర్ఫోర్ దిస్ ఈజ్ ఫార్మ్డ్ ఈజీలీ, మేజర్ ప్రొడక్ట్ ఫార్మ్ అవుతుంది. అండ్ స్పెసిఫిసిటీ చూడండి ఇక్కడ, వెదర్ స్పెసిఫిక్ గా ఒకటే కాంపౌండ్ ఇస్తుంది అండ్ ఇట్స్ కాల్డ్ as specificity. Okay, this one E2 has only one course to follow and the outcome depends on which diastereomer of the starting material is used. ఏ diastereomer వాడుతున్నాం అనే దాన్ని బట్టి ప్రొడక్ట్ వస్తుంది, ఒకటే ప్రొడక్ట్ వస్తుంది. దట్ ఈస్ కాల్డ్ as stereospecific nature. ఇది రీజన్. స్టీరియో సెలెక్టివ్ అంటే ఏంటిది, స్టీరియో స్పెసిఫిక్ అంటే ఏంటిది. ఓకే, ప్రిఫర్డ్ ప్రొడక్ట్ వస్తే దాన్ని కైనెటిక్ కంట్రోల్, మోర్ స్టేబుల్ ప్రొడక్ట్ వస్తే థర్మోడైనమిక్ కంట్రోల్. నేను నేర్చుకున్నాం అది. ఓకే, స్టీరియో స్పెసిఫిసిటీ ఆఫ్ మెంథాల్ క్లోరైడ్ చాలా ఇంపార్టెంట్ ఎగ్జాంపుల్ మై డియర్ స్టూడెంట్స్. దిస్ వన్ ఎలిమినేషన్ ఆఫ్ డయాస్టీరియోమర్ ఏ. ఎలిమినేషన్ ఇక్కడ చూడండి, ఇక్కడ 2 చాయిసెస్ ఉన్నాయి మనకు. ఇక్కడ హైడ్రోజన్స్ ఉన్నాయి, వీఆర్ హ్యావింగ్ 2 హైడ్రోజన్స్ ఆన్ దిస్ సైడ్, వీఆర్ హ్యావింగ్ hydrogens. Here also we are having 1 hydrogen. 1 hydrogen is there here. Poor becomes poorer. అంటే ఇది దిస్ ఈజ్ సెడ్జెఫ్ ప్రోడక్ట్ అంటాం. ఈ రూల్ ఫాలో అయ్యి వస్తే దాన్ని సెడ్జెఫ్ ప్రోడక్ట్. ఇది హాఫ్మన్ ప్రోడక్ట్ అంటాం, దీన్ని హాఫ్మన్ ప్రోడక్ట్. అగెనెస్ట్ మన పూర్ బికమ్స్ పూరర్ అనే దానికి వస్తే హాఫ్మన్ ప్రోడక్ట్. అదే ఇక్కడ చూడండి, యాంటీ ఎలిమినేషన్ ఈజ్ మోస్ట్ ఇంపార్టెంట్ హియర్. ఇక్కడ చూడండి సిఎల్ ఉన్నది, ఇది ఎక్కడ ఉంటుంది, దీనికి ఆపోజిట్ గా ఉంటుంది. కాబట్టి దేర్ ఈజ్ ఎవ్రీ చాయిస్ ఫర్ దిస్ వన్ టు గెట్ ఎలిమినేటెడ్. ఇక్కడ 2 ఉన్నాయి, ఒకటి ఇట్లుంది, ఒకటి ఆపోజిట్ గా ఉంది, 2 చాయిసెస్ ఉన్నాయి. ఇది కిందికి ఉంది అంటే క్లోరిన్ ఎటువైపు ఉంటే మీకు తెలుసు, 3 డైమెన్షనల్ స్ట్రక్చర్ కనుక చూస్తే దెన్ ఇట్ ఈస్ యాంటై కాబట్టి ఈజీగా ఎలిమినేట్ అవుతుంది. కానీ ఇక్కడ చూడండి, ఇక్కడ హైడ్రోజన్ క్లోరిన్ ఒక్క దిక్కే ఉన్నాయి, ఒకే వైపు హైడ్రోజన్ ఉంది, క్లోరిన్ ఉంది, కాబట్టి ఒకే సైడ్ ఉంటే ఎలిమినేట్ కావు. ఆపోజిట్ సైడ్ ఇక్కడ వైపే ఉంది కాబట్టి ఖచ్చితంగా 100% ఇదే వస్తుంది. ఓకే, దిస్ ఈస్ కాల్డ్ యాజ్ స్టీరియోసెలెక్టివ్ నేచర్, స్టీరియోస్పెసిఫిక్ నేచర్ ఆఫ్ మెంథాల్ క్లోరైడ్. Okay, menthol chloride, stereospecificity. Though both are diastereomers, rendu వేరు వేరు, both are said to be the diastereomers. ఓకే, ఇక్కడ చూడండి యాంటై, నేను చెప్పినట్టే ఇక్కడ చైల్డ్ ఫామ్ లో క్లియర్ గా ఎక్స్ప్లెయిన్ చేస్తాడు. ఓకే, క్లియర్ గా ఇక్కడ మనకు క్లియర్ గా అర్థమవుతుంది. ఏక్సియల్ ఫామ్ లో, ఈక్వటోరియల్ ఫామ్ మీకు తెలుసు. Elimination from Z isomer of vinyl bromide gives an alkyne rather faster than E isomer. Okay, alkyne వస్తుంది, E isomer కంటే Z isomer లోనే తొందరగా వస్తుంది. అది ఎందుకంటే అగైన్ అండ్ CA ఆర్ ఆపోజిట్ టు వన్ అనదర్. ఓకే, స్టీరియో సెలెక్టివ్ నేచర్. Regioselectivity of E2 eliminations. Acid catalyzed elimination tertiary produces tri-substituted alkene. E2 elimination with hindered bases typically gives less substituted double bond. దీన్ని హాఫ్మన్ ప్రొడక్ట్ అంట. Okay, here we are using this one, ring hydrogens, more hindered, no reaction. ఇక్కడ the alkene exo double bond is formed. దీన్ని ఎండో డబుల్ బాండ్ అంటాం. దీని బదులు ఇది వెళ్ళిపోవడం ఈజీ, లెస్ హిండర్డ్. ఓకే, దట్ ఈస్ అబౌట్ దిస్ కాంపౌండ్ వేర్ ద హైడ్రోజన్స్ ఆఫ్ మిథైల్ ఆర్ రిమూవ్డ్, నాట్ దిస్ వన్, ఈవెన్ దో ఇట్ ఈస్ ఎక్సియల్. బికాజ్ ఇక్కడ హిండ్రెన్స్ ఎక్కువ ఉంది. ఓకే, ఓఆర్ దట్ ఈస్ బేస్ షుడ్ అటాక్ దిస్ హైడ్రోజన్, ఇట్ ఈస్ నాట్ గోయింగ్ టు అటాక్. వై? బికాస్ ఆఫ్ ద బల్కీనెస్ ఆఫ్ ద బేస్. బల్కీ బేస్ ఎక్కువ మనం బేస్ వాడితే, అంటే టెర్షరీ బ్యూటైల్ పొటాషియం టెర్షరీ బ్యూటాక్సైడ్ తీసుకుంటేనేమో ఇది 73%, ఇది 28%. సోడియం ఇథాక్సైడ్ తీసుకుంటే ఇది 69%. ఇది చాలా మంచి ఎగ్జాంపుల్ మై డియర్ స్టూడెంట్స్. రీజియో సెలెక్టివిటీ, దీన్ని ఇక్కడ బోత్ ఆర్ E2 ఎలిమినేషన్స్. ఓకే, ఇక్కడ దీన్ని ఏమంటాం, దీన్ని పూర్ బికమ్స్ పూరర్. ఎక్కడ ఇది సెడ్జెఫ్ ప్రోడక్ట్, ఇది హాఫ్మన్ ప్రోడక్ట్. ఇది సెడ్జెఫ్ ప్రొడక్ట్, ఇది హాఫ్మన్ ప్రొడక్ట్. ఇక్కడ వాడిన బేస్ ఏంటిది? సింపుల్ బేస్. ఇది బల్కీ బేస్. ఇట్లుందనమాట. ఓకే. టెర్షరీ బ్యూటాక్సీ, టెర్షరీ బ్యూటైల్, మీథేన్, ఈథేన్, ప్రొపేన్, టెర్షరీ బ్యూటైల్ ఇది. ఇదేమో జస్ట్ ఇంతే, ఇథైల్, సోడియం ఇథాక్సైడ్ ONA. ఇది సింపుల్ బేస్. ఇది సెట్జెఫ్ ప్రొడక్ట్. మోర్ సబ్స్టిట్యూటెడ్ ఆల్కీన్ ఫామ్ కావడాన్ని సెట్జెఫ్ ప్రొడక్ట్ అంట. అందుకంటే సెట్జెఫ్ అనే సైంటిస్ట్ ప్రతిపాదించిండు కాబట్టి. ఇది హాఫ్మన్ ప్రొడక్ట్ అంట. ఇది హాఫ్మన్ ప్రొడక్ట్ తక్కువ వచ్చింది, ఇక్కడ ఇది ఎక్కువ వచ్చింది. హాఫ్మన్ బల్కీ బేస్ వాడండి, హాఫ్మన్ ప్రొడక్ట్ పొందండి, అంతే. E1CB ఇది ఒక రకమైన ఎలిమినేషన్ రియాక్షన్. ఇంతకుముందు నేను చెప్పడానికి ప్రయత్నించినది, ఇక్కడ ఫస్ట్ ఇక్కడ బేస్ ఈజ్ గోయింగ్ టు రిమూవ్ ద ప్రోటాన్. ఇక్కడ చూడండి డబుల్ బాండ్ ఫామ్ అవుతుంది ఇక్కడ. తర్వాత ఇది రీప్లేస్ అవుతుంది. తర్వాత దిస్ OH ఈజ్ ఆల్సో రిమూవ్డ్. ఓకే, దిస్ ఈస్ రిమూవ్డ్ లైక్ దిస్. ఇది దిస్ ఈజ్ కాల్డ్ E1CB రియాక్షన్. E1CB రియాక్షన్ చూడండి. ఫస్ట్ బేస్ E1 ఎలిమినేషన్ లో బేస్ ఎప్పుడు అటాక్ అవుతుంది? సెకండ్ స్టెప్ లో. E2 ఎలిమినేషన్ లో బేస్ యాజ్ వెల్ యాజ్ ద లీవింగ్ గ్రూప్ టేక్స్ ప్లేస్ సైమల్టేనియస్లీ, అంటే ఒకటే స్టెప్ లో. థర్డ్ దాంట్లో E1CB లో బేస్ ఈజ్ గోయింగ్ టు అటాక్ ఫస్ట్, ఆఫ్టర్ దట్ ఎలిమినేషన్ ఆఫ్ ద లీవింగ్ గ్రూప్. ఇక్కడ బెస్ట్ లీవింగ్ గ్రూప్స్ ఉంటే ఇవన్నీ లీవింగ్ గ్రూప్స్ బట్టి కూడా ఇది జనరల్లీ టేక్స్ ప్లేస్ ఇన్ ఆల్ఫా హైడ్రోజన్ కంటైనింగ్ కాంపౌండ్స్. లీవింగ్ గ్రూప్ కూడా అడ్జసెంట్ గా ఉండాలి. ఇట్లా ఇదే స్ట్రక్చర్ ఉంటేనే ఇది E1CB రియాక్షన్స్ అవుతాయి. ఈ సెకండ్ ఆర్డర్ రియాక్షన్. వై? బికాస్ E1 అంటే యూని ఆర్డర్ అనుకుంటాం, కానీ కాంజుగేట్ బేస్ కూడా ఫామ్ కావాలి కదా, అందుకే ఇది సెకండ్ ఆర్డర్ రియాక్షన్స్. ఓకే, దే ఆర్ ఆల్సో రీజియోసెలెక్టివ్. ketene is formed. ఇవన్నీ మనకు అవసరం లేదు. థ్యాంక్ యూ స్టూడెంట్స్ ఫర్ బేరింగ్ మీ ఫర్ ఆల్ దిస్ టైమ్. అండ్ డౌట్స్ ఉంటే చెప్పండి. ఇంకా we had seen 3 types of reactions. One is E2 reaction, E1 reaction, third one is E1CB reaction. Okay, any doubts? ఏమైనా డౌట్స్ ఉంటే చెప్పండి. మనము క్వశ్చన్స్ జామ్లో వచ్చిన క్వశ్చన్స్ అవన్నీ మనము నెక్స్ట్ క్లాస్లో కానీ తర్వాత కానీ చూద్దాం. ఎందుకంటే జామ్లో వచ్చిన క్వశ్చన్స్ ద్వారా మనము కొంత అక్వైంటెన్స్, అంటే ఎటువంటి క్వశ్చన్లు వస్తున్నాయి అవన్నీ తెలుసుకోవచ్చు. రేపటి క్లాస్లో ఆక్సిడేషన్ రిడక్షన్ కూడా చూద్దాం. ఆక్సిడేషన్ రిడక్షన్ రియాక్షన్స్ చూస్తే రియాక్షన్ మెకానిజం మ్యాక్సిమం అయిపోతున్నట్టుంది. ఓకే, థ్యాంక్ యూ స్టూడెంట్స్, బాయ్. ఎనీ డౌట్స్? అర్థమైంది ఏమన్నా? Okay, you can unmute and talk also. Thank you, Anjali. Okay.